I want you to imagine just for a second that, well, that you suddenly discovered that one of the most famous, most foundational physics experiments in human history was interpreted completely wrong.
And not just for a few years, but for, over a century.
Right. Over a century. We are talking about the Michelson-Morley experiment. I mean, we've all been taught that it proved the speed of light is constant. And to make the math work, physicists basically decided that space itself physically shrinks when things move. But what if space doesn't actually shrink at all?
It is a radical proposition.
It really is. What if the physical ruler you're holding in your hand right now is actually just an illusion created by delayed information?
It completely upends how we visualize our reality. Welcome to this deep dive. Today, our mission is to explore a fascinating theoretical physics dialogue that radically reinterprets the laws of the universe. What's fascinating here is how we're pulling from a very dense, highly analytical set of sources. They are proposing that classical Cartesian space, that familiar, flat, three-dimensional grid we all assume we live in, is actually a perceptual illusion.
Okay, let's unpack this. Because if you have ever felt like quantum physics or, say, relativity is just painfully hard to visualize, this deep dive is going to offer you a completely new lens.
Absolutely.
We're going to swap out your standard physical rulers for something called time distances. We're going to turn flat, boring space into a curved sphere of delayed information. And we're going to see how light actually travels.
And the journey of this theory is incredible. We're going to start with the core mathematical contradiction of that classic experiment, move into the visual illusions of the night sky, and eventually touch on how human biology shapes our physics.
Bringing in Jacques Lacan's psychoanalysis, too.
Right, and the mysteries of quantum entanglement. It's a journey from the mechanics of moving light to the very boundaries of human perception.
So let's jump straight into the numbers that caused over a century of headaches. We all know the basic Michelson-Morley setup, right? Splitting light down two arms at right angles to see if the beams return out of sync.
Yes, but the sources break this down with some very specific values to illustrate the flaw in classical thinking. Let's say we've got the arm length set to 10.
Okay, 10.
And the whole apparatus is hurtling along the horizontal x-axis at 60% the speed of light, 0.6 c.
So walk me through what actually happens to the vertical beam first, the y-axis. It can't just be going straight up and down from the perspective of the stationary observer, right?
It can't, because the entire device is moving sideways at 0.6 c. That vertical beam traces a diagonal triangular path through space.
Right, because the top mirror moved while the light was traveling.
Exactly. If you're standing still watching it zoom by, the light has to travel diagonally up to hit the top mirror and diagonally down to hit the center mirror again. When you calculate that Pythagorean path, the apparent vertical speed of the light relative to the device is 0.8 c.
0.8 c.
Okay. And the math tells us that the round trip for that vertical beam takes exactly 25 seconds.
Okay, 25 seconds for the vertical round trip. Got it. But the horizontal beam, the x-axis, that has to look completely different. I mean, that light is shot forward, but it's chasing a mirror that is actively running away from it at 60% the speed of light.
That is the crux of the problem. It takes a massive amount of time for the light just to catch up to that retreating mirror on the outward journey.
Because the mirror keeps moving.
Right. According to the classical calculations in our sources, it takes a full 25 seconds just for that first leg of the trip.
Wow, just the outward trip. And then on the way back, the light bounces off the mirror and heads toward the center, but now the center is rushing forward to meet it.
Which means the return trip is incredibly fast. It only takes 6.25 seconds.
Let me make sure I'm visualizing this gap, because this is where the trouble starts. 25 seconds out, 6.25 seconds back. That's a total round trip of 31.25 seconds for the horizontal x-axis beam.
Correct.
But the vertical beam only took 25 seconds.
That leaves us with a missing 6.25 seconds. The horizontal beam takes exactly 6.25 seconds longer to return to the detector.
Which means they absolutely should not arrive at the same time. If you're looking at the detector, you should see a massive shift in the interference fringes, because those two light beams are fundamentally out of sync.
You should. But we know what actually happened when the experiment was run historically.
There was zero difference.
Zero. No shift in the interference fringes whatsoever. The beams arrived at the exact same time.
This is the contradiction that effectively broke physics at the end of the 19th century. And the historical fix for this missing 6.25 seconds came from Hendrik Lorentz, right?
Yes. He looked at that math and claim that the only way it could possibly work is if the horizontal arm of the device physically shrank.
What we now call Lorentz contraction.
Exactly. He argued the metal arm physically compressed by a factor of 0.8 to make up for the time difference.
But based on our source material, we're taking that idea of a physical metal arm shrinking in the real world, and we're throwing it out entirely.
We are.
We don't need the universe to physically compress. We need to completely change how we think about the concept of distance itself. We need to stop measuring space in meters and start measuring it in what the text calls time distance.
Time distance is a crucial paradigm shift. It means we should measure the distance between 2 points, not by laying down a physical ruler, but by measuring how many seconds it takes light to travel between them.
So Tokyo to Mount Fuji isn't 100 kilometers away. It's 0.00033 light seconds away.
Exactly. The distance is literally defined by the information delay. And this brings us to what the sources highlight as the fundamental flaw of classical physics.
The illusion of the simultaneous stamp.
Yes, the simultaneous stamp is the assumption that when we look at a flat 3D Cartesian grid, like a graph on a piece of paper, or the room you're sitting in right now, every point on that grid exists at the exact same t=0 moment.
We just naturally assume that right now, everywhere in the universe, it's exactly the same right now.
We do. And it's deeply flawed.
I love the analogy the sources use to break this illusion. They talk about the night sky, specifically the constellation of the Southern Cross. When you stand on Earth and look up at those stars, you see this beautiful flat cross shape facing you perfectly.
And your brain naturally assumes they're all pasted onto a flat ceiling existing simultaneously.
But that flat geometric shape is a complete hallucination of our perspective. In reality, those stars are scattered at entirely different, staggering depths of space and time.
Right. One star's light might have taken 10 years to reach you, and others might have taken 100. We force a flat, simultaneous geometric illusion onto a reality that is deeply staggered in time.
And the sources argue that the interferometer moving at 60% the speed of light is exactly like this tilted constellation.
It is. We think the two arms of the device are flat and existing at the exact same time. But from the perspective of the underlying electromagnetic field, they're tilted and staggered in time.
Which perfectly sets up the radical solution to our missing 6.25 seconds. We have to move away from that flat Cartesian grid and introduce what the sources call a complex sphere model.
Yes.
Okay, let's unpack this because here's where it gets really interesting. If space doesn't shrink, and if the arms didn't physically compress, how did the beams arrive at the same time?
The breakthrough is realizing that the light isn't traveling on a flat plane at all. The sources emphasize a very specific geometric reality. The light rays on both the x-axis and the y-axis were actually traveling along the equivalent of the globe's lines of latitude on a great circle course of the complex sphere.
Wait, on both axes?
Yes, because they were moving on this great circle course of a complex sphere, there was no shift in the interference fringes in the Michelson-Morley experiment.
A great circle course, like how airplanes fly curved routes over the Earth to take the shortest path.
Exactly like that. But in this case, the globe is a sphere of complex time, because the light rays on both axes are tracing these great circle paths, equivalent to lines of latitude. Their relative phase is preserved.
So the missing 6.25 seconds on the horizontal x-axis didn't physically vanish.
No. Instead, that time equates to a 90-degree phase rotation in complex space.
A 90-degree phase rotation. That sounds like some heavy jargon. How should we visualize a delay turning into a rotation?
Think of it like a spiral staircase. From directly above, if you're looking at a flat 2D floor plan, it looks like someone walking on that staircase is just moving in a tight circle and getting nowhere.
Right, you'd think their forward progress is completely stalled.
That is our missing time. It looks like it just vanished from the flat grid. But in 3D space, you realize they're actually moving upward. The forward motion didn't vanish. It shifted into a geometric dimension, the vertical axis, that you weren't tracking from your flat perspective.
Oh, wow. So in our physics problem, the delay on the x-axis is absorbed as a phase rotation along that complex sphere.
Precisely, allowing the light beams to effectively sync back up without any physical shrinking involved.
That completely recontextualizes the entire experiment. It's like the light took a shortcut through a hidden dimension of time rather than physically traversing space. It is absolutely mind-bending.
It is.
But to really grasp how we can be so thoroughly tricked into seeing a flat 3D world when it's actually a complex sphere of delayed time, The sources introduce us to this conceptual ultimate supervisor, Observer 3.
Observer 3 is crucial for understanding the latency of information. Observer 3 is positioned high above our moving experiment at a z-axis coordinate of 100. They're looking down at the flat Gobsi plane where the interferometer is operating.
Okay.
But from their perspective, because of the delay of light traveling up to them, that flat grouped plane doesn't look flat at all.
The sources use this amazing movie theater analogy for Observer 3. Walk me through that, because it completely changed how I think about the concept of now.
Put yourself in Observer 3's shoes. You're hovering way above this experiment. When you look down, you aren't seeing a flat floor. Because light from the outer edges of the plane takes longer to reach you than light from the center, the floor looks warped.
Like it's bowing downwards.
Right. It looks like a curved spherical cap sinking into a funnel. And more importantly, the image reaching your eyes isn't a live feed.
Because you're sitting in a giant movie theater, essentially. And the screen you're looking at is that curved spherical cap. And the movie playing on that screen is the historical time map of the universe from exactly 141 seconds ago.
Exactly. This brings us to the concept of double timestamps, which are carried by what the text calls event information diffusion lines.
Double timestamps. Okay, how does a single ray of light carry two different stamps of time?
Imagine a ray of light hitting the very center of that plane at the bottom of the funnel and then bouncing up to Observer 3. That single ray of light carries a history. The first stamp is the time it originally left the outer boundary of the sphere.
Let's say t equals negative 141.
Perfect. And the second stamp is the time it passed through the local plane beneath you. Let's say t equals negative 100.
So the light is basically carrying a shipping log. It's saying, hey, I originated 141 seconds ago, but I passed through your specific local neighborhood 100 seconds ago.
That's a great way to put it.
But as humans, our biological camera eye, our natural perception, completely ignores this incredibly complex shipping log. We strip away the history of the light.
We do.
We pretend the image just arrives at our eye instantly, all at t equals 0. We take that deeply warped funnel of time and mentally flatten it into a piece of paper.
And this biological limitation isn't just a quirky physics footnote. It is a profound philosophical problem about how human beings construct reality. This is where the source material makes a fascinating pivot and brings in Jacques Lacan, the French psychoanalyst.
Yeah, that transition threw me at first. Mapping theoretical physics to a psychoanalytic framework is a massive conceptual leap. But when you realize that our biological hardwiring literally forces this flat grid upon us, it starts to make sense.
Lacan argued that human experience is divided into three distinct orders: the imaginary, the symbolic, and the real. The sources map these three psychological orders perfectly onto our physics problem to explain why we get reality so wrong.
Let's walk through how they apply. First, we have the imaginary. In Lacanian terms, this is the illusion we create to make sense of the world.
Right.
In our physics context, the imaginary is the flat 3D Cartesian grid. It's the illusion where we assume everything is happening at once, simultaneously.
It is the flat Southern Cross in the sky. It's our comfortable but ultimately false assumption of reality. We are biologically constrained to perceive the world this way because tracking double timestamps and complex phase rotations in real time would just overload our brains.
Then we have the symbolic. In psychoanalysis, this is the structured world of language and laws. But in this physics framework, the symbolic is the complex sphere we've been talking about.
Yes, the symbolic is the mathematical reality governing the delayed information. It is where light travels along those great circle courses, where delays are absorbed as phase rotations, and where event information diffusion lines carry double timestamps.
It's the hidden, mathematically rigorous operating system of the electromagnetic universe.
Exactly. We can't see it with our naked eye, but we can map it with our math.
And finally, there is the real, or as the sources frequently refer to it, the territory. This is the raw, fundamentally unknowable universe outside of our subjective perception entirely.
It's whatever actually exists before light even bothers to carry a delayed image to our camera eye.
And exploring this concept of the territory brings us to perhaps the most ambitious idea in the entire source material, the concept of the public space.
It's quite a leap.
This part is wild. I want you to imagine that humans, atoms, and even quantum particles are all trapped inside their own individual complex sphere operating systems. We are all living inside our own personal bubbles of delayed light, interacting only with the delayed light radiating from others.
This immediately raises a massive question. If we are all trapped in our own spheres of delayed information, what lies between us?
Right. What is the medium outside these individual spheres?
The sources propose that this underlying medium is the public space. And the implications here are staggering, particularly when you try to solve mysteries like quantum entanglement.
Quantum entanglement has always felt like magic to me. You have two particles that act like they're connected instantly, even if they are billions of light years apart. It completely defines the speed of light, which is supposed to be the absolute speed limit of the universe.
It defies the speed of light because, according to this framework, in the public space, information does not need to travel via electromagnetic waves. The speed of light is merely a rule for the symbolic order. It's the speed limit of the delay inside our complex spheres.
But in the public space, the fundamental connection does not rely on light at all.
The sources mention Dr. Akifumi Higashi here, and his concept of the dense clock field. This dense clock field is proposed as a potential physical architecture governing this underlying network.
It is the fabric of the public space itself. It suggests that our perceived distance, the millions of light years between entangled particles, is merely an artifact of the delayed light within our complex spheres.
Because in the dense clock field of the public space, those particles might not be distant at all.
Exactly. They are part of a unified, instantaneous whole.
So what does this all mean? It means that you and I, we are navigating the universe using a map. And that map is painted entirely by delayed light, carrying complex double timestamps, tricking our biological camera eyes into seeing a flat, instantaneous grid.
While the true territory, the reality beneath the map, operates on a much deeper, instantaneous level of connection.
We're living our entire lives in the delay, but the universe operates in the instant. It is a profound paradigm shift. It tells us that our intuition about space, distance, and time is fundamentally constrained by the biological and physical limits of how we process information. For over a century, we mistook the delivery mechanism, the delayed light, for the reality itself.
Let's quickly recap the incredible journey we just took through these sources. We started by ditching Hendrik Lorentz and his idea that physical metal arms shrink when they move fast.
Thankfully.
Instead, we traded flat Cartesian space for the complex sphere. We learned that the interference fringes in the Michelson-Morley experiment didn't shift because the light on both axes was actually traveling on a great circle course, equivalent to lines of latitude, using phase rotation to maintain sync.
We explored Observer 3 sitting in a warped movie theater reading double timestamps.
And finally, we peeked outside the matrix of our own perception, past the imaginary and the symbolic, into the non-electromagnetic public space.
It is a framework that challenges everything from classical mechanics to relativity, offering a deeply unified way to look at the cosmos. One that embraces the delay of information as the very fabric of perceived space, rather than an inconvenience to be mathematically shrunk away.
I want to leave you with a final lingering question to mull over. If our perception of a unified 3D space is really just a movie screen projected by delayed light from our individual complex spheres, what happens to our entire concept of distance if we ever figure out how to interact directly with that non-electromagnetic public space?
It's a great question.
If we can tap into Dr. Higashi's dense clock field, could here and there actually be the exact same place in the underlying reality?
It implies that distance as we know it is just an illusion of the light. Without the light, everywhere might just be here.
Something to think about the next time you look up at the Southern Cross and realize you are staring into a deep, staggered well of time. Thank you so much for taking this deep dive with us. Keep questioning the reality around you, and remember, the map is not the territory.